Hello students. From today the vector algebra lecture for vector algebra will be started. This is your unit 5. Now before beginning to this chapter, I will discuss some of the basic definitions and the basic terminology of vector algebra. Now what is a vector? It is defined by a quantity which has a direction, a magnitude as well as a direction. So just look at this picture. A vector now can be represented by this point 5 7. Now whatever we have drawn in a graphical plane till now, each and every point it can be represented by a vector, just like this. Look at this point, this endpoint 5 7 point, and the x-axis. The x-axis it cuts the 5, that is 5 unit, and y-axis cuts 7 unit. Okay, so if we point this, that is 5 7 point, it is denoted by 5i and 7j. That is, if I denote this x-axis as I direction and j-axis as j direction, and each and every unit vector can be represented by I, 2i, 3i, 4i, 5i, like this. And each and every unit vector in the y direction can be represented by 1j, 2j, 3j, 4j, 5j, like this. Then the 5 7 point it can be represented by 5i plus 7j. So now now we can denote this 4 2 point, we can denote this 1 5 point as also 1i plus 5j, 4i plus 2j, like this. In the other manner we can also think about like this. If this, suppose this 1 5 point, this vector, so the middle vector, to denote this middle vector, there is this resultant vector, this middle vector is the resultant vector of these 4 2 and 1 5. There is, suppose someone is pulling in this direction 4 2 direction, and some other person is pulling in 1 5 direction. Okay, and if we consider this point, if we consider this point as a particle, and this particle, or this is an object, and this object can be pulled by this direction by one man and this direction by another person, then that resultant velocity or resultant direction of this and this will be this 5 7. So this can also be is a another significance or another definition of vector can be defined like this. Or simply, to denote every vector point in this plane, we can denote these 5 7 or 4 2 or 1 5. There is a paired point or paired number, and which can be represented by 4i plus 2j, 1i plus 5j, 5i plus 7j, like this. Now come to vector addition. Now look at this picture, this addition, there are, we have considered two vectors, this vector a and this is vector b. Now if we add these two vectors a and b, that is a plus b, the resultant vector will be this vector c, that is the this middle direction. So it is simply just we can denote, or we can denote this, or this middle, there is a resultant vector, it can be represented by this. If I want to go from a point to c point, then we have to go first a to b and b to c. Or if I look at this direction, then a to d and d to c. Now a to d, this is b vector, and d to c, it is a vector, so obviously b plus a. Or if I consider in this direction, a plus b, this is also denote this middle resultant vector, that is c vector. So this is a vector addition. Similarly, if I consider in the, just like the previous slide what already I have discussed, if I consider the c direction, That is, we can also consider like this. There is this C point or the middle direction. It can be the resultant of AD and AB. That is, this object A can be, it is pulled by two persons. In one person is pulling this A object in AD direction, and another person is pulling this object in AB direction, and resultant of these two vector or these two direction, it is the C vector, that is the C direction. So addition of A plus B, this is A and this is B. Now addition of A plus B, obviously the resultant vector is C. So the addition can also be defined like this. Now this is absolute value of the vector. This is nothing but, if I do not consider the direction, only we consider the value of the vector, then the absolute value will be measured by this. I already told that the any vector, that is suppose this xyz point, there is xyz in a vector point, it can be represented by xi, that is in this x direction the unit vector is I. So obviously in this direction, if the unit vector is I, so the this direction it will be x into y, that is 0 to x, and this O to Z in the Z direction, obviously it is Z into K, because in the Z direction the unit vector is K. Now if I want to move to this Z quantity, then obviously, and unit vector is K, obviously it will be Z into K. Similarly in the direction of Y, we can see that J is the unit vector. So obviously we if we want to go Y unit of distance, then obviously it will be Y into J, because J is the unit vector of in the Y direction. So now this point that is A vector, it can be represented by xi plus yj plus zk. And if I want to find out only the uh, absolute value, it is only the value of this vector without any direction, obviously we have to remove this ij and k, and this is nothing but, it can be represented by this simple formula, that is it can also be derived by simple Pythagoras theorem, that is the right angle triangle theorem. If it is just two-dimensional vector, then obviously the Pythagoras theorem will be a root over of x square plus y square, that is x direction and y direction. If the quantity or the value in the x direction is x and the value in the y direction is y, so applying the Pythagoras theorem, it will be square root of x square plus y square. Now in this case another direction z is added, so obviously the value will be square root of x square plus y square plus z square, so it will give us only the value of this vector without any direction. Now come to the product of two vectors. The product can be of two types. One is dot product and another one is cross product. So cross product can also be written as vector product because it has a direction. But dot product, it does not have any direction. That is, A and B, the two vectors are given. If uh, I perform the product of these two vectors as a dot product, that is A dot B. Just look at this A dot B. So A dot B, this is the product of these two vectors, but the resultant, that is the outcome of this multiplication, will give us a scalar quantity, and which is the absolute value of A, the absolute value of B into the cos theta. If theta is the angle between A and B, so the resultant of this multiplication is a scalar quantity rather than a vector. But in case of cross product, so it is a vector quantity. Now cross A cross B, look at this, A cross B, it is equals the absolute value of A, the absolute value of B multiplied with sine theta, where theta is the angle between A and B, and multiplied with a n. What is n? N is a unit vector, and this direction of this unit vector n, it is defined by the direction of this multiplication. That is, if I write a cross b, a cross b means we are going to b from a. That is, just look at this picture. This is a vector and this is b vector. If I just write a cross b, it means we are going from a to b. So from a to b, it means this direction is like this. Just we can consider, if I open the cap of a bottle in this direction, it will be in the upside. That is, the cap of this bottle, it will be opened, so the direction will be upward. So from this direction a to b, this direction, the vector direction, the resultant vector direction will be upward. Similarly, if the direction is just the opposite, that is, just consider the bottle cap. If I want to just tight the bottle cap, or just close the bottle with the cap, then we have to just think about the direction from b to a, that is b cross a. So if the multiplication is b cross a, obviously the direction of this vector will be just opposite direction. So this a cross b, it is the direction of the vertical direction, vertically upward. If a and b will be in this side, that is a to b, that is direction is this to this, then it will be upward. And if it is a b to a, that is direction is this to here, then it will be just downward, the opposite of this direction. Now another this representation of the cross product, it can also be represented by this. This can be, an example is given where a and b are two vectors. A is 1 2 1 3 4 and b is 2 7 5. I already told you that any uh, paired number or any triplet number like this 1 3 4, it actually represents a vector point, that is 1 into I plus 3 into j plus 4 into k. Similarly, 2 7 minus 5, it is 2 into I plus 7 into j minus 5 into k. And the formula of cross product, it can be written also like this: ijk 1 3 4 2 7 minus 5. And if I just break this um, determinant, and after breaking this determinant, we will have this. So just simply we can apply this formula also to find out the direction of this, to find out the cross product. And just look at this a cross b, it is a vector point. Just other than the cross dot product is a scalar quantity. So after multiplication, that is a dot b, it is that was a scalar quantity, but in vector product a cross b, it is a vector quantity, minus 43i plus 13j plus k. So obviously it's a vector point. Now come to the totally different thing, vector functions. Now just like vector point, just remember the vector point 1 2 3, just a triplet 1 2 3, it can be represented by as 1i plus 2j plus 3k. Just replace, now I'm just replacing that point, that is 1 2 3 points, with some functions ft, gt and ht. That is, other than the points, we are writing here some function. And the function of t, look at this, the variable t is fixed, that is, it is a parametric form of the function, the parameter is t. So ft, gt and ht, three different functions but having the same independent variable or the same parameter t. So the vector function, it can be represented as ft into I plus gt j plus ht k. And look at this function is actually a function whose codomain is Rn. That is, if we write 1 to 3, so obviously the codomain will be R3. If I write 1 2, then the codomain is R2. That is only either pair of numbers or triplet of numbers, or if the dimension is more than 3, that is if I write here 1 2 3 4, obviously it will be R4. Similarly, in case of R4, four different functions with the same independent variability will be given. So the vector function, just simply it's saying that other than the points, if I say vector function, just the point will be represented, or just the point will be uh, just removed, or the points will be replaced by some functions, the functions of same parameter. That is, if xt, if I write here as a point 1 into I plus 2 into j plus 3 into k, so in a vector function the same point can be replaced by some three different functions, fi, ft into I, gt into j plus ht into k. Now come to the limit. Just like the limit of real number, the limit of a vector number or a limit of a vector quantity, it can also be given as a same manner. That is, if I say the limit x tends to x0, fx equal to L, this fx is a functional limit, is a function of a real variable x, and the limiting value of this function is L as x tends to x0. It means that when this point x reaches to the point x0, the functional value fx, it reaches to a particular point L. So in the similar manner, when we are defining, or when we are going to define the vector function, simply this fx function, it can be replaced by xt, that is a vector function. That is, fx function is just simply, if I just say fx equal to x square, this x square, if it is a vector function, then we can write here as a x into I plus y into j plus z into k, that is xt into I plus yt into j plus zt into k. That is, it is a vector function. This fx function, it is a real function, but this xt function, it is a vector function. So I already defined the what is vector function and how a vector function can be represented, can be represented in the previous slide. The similar function can be used here. Now look at this limit t tends to t0, xt equal to x0. What does it mean? This x0 is actually a vector point. Now just if I look at this, compare these two definitions, this limit, functional limit, is actually a scalar point L. This is not a vector point, but in this case this is a vector function. As t tends to t0, it, this function tends to the limit x0. This x0 is a vector point, but in this case this capital L is a real number, or it is a scalar point. In the similar manner, as a limit, the continuity of the vector function can also be defined. Just the scalar function, it is just replaced with the vector function. That is, in this definition, limit x tends to x0 fx, it is fx0. This fx, this fx0, all these functions are scalar function. That is, there is no I, j or k. But in vector function, this fx function, it is replaced with this xt functions. That is, this equal to xt0 as t tends to t0. This xt is a vector function, and this xt0 is also a vector function, is a vector point. So this is the end of the slide. Now I will upload the lecture notes and also some examples in the UMS and as well as the LPU live. Thank you.